So these formulas, lambda is equal to h by mc and lambda is equal to h by p. Okay, p and enti momentum of the particle. Momentum means it has mass and velocity. Velocity. So the product of mass and velocity is known as momentum. The product of mass and velocity is known as momentum. So here p. So this is the formula for particle nature, and this is for wave nature. And next to Heisenberg principle. What is Heisenberg principle? So what is Heisenberg principle? It is impossible to determine position and velocity of the particle at a time. Okay. So simultaneously, we cannot determine the position and velocity of a particle. Okay. So that is what Heisenberg uncertainty principle. So there is Heisenberg uncertainty delta x delta, delta p is greater than or equal to h by 4 pi. So this is the Heisenberg uncertainty principle. So delta x is the uncertainty in the position and delta p is the uncertainty in the momentum. Uncertainty in the momentum. Planck's constant. Okay, this is what Heisenberg uncertainty principle, right? So based on these fundamental theories, we can derive the Schrodinger wave equation. Schrodinger wave equation. Based on these fund, so we can derive the mathematical expression for the Schrodinger wave equation. So next to Schrodinger wave equation. Right. The Schrodinger wave equation describes the wave nature of the electron in the atom. So it describes the wave nature. The electrons in the atoms are moved around the nucleus in the form of wave అని చెప్తున్నాడు. Okay. So where the electrons are present in the atom? Electrons are present in the atom around the nucleus in a circular. Electrons are revolving around the nucleus. According to Schrodinger, what is it? So, the electrons are revolving in a, so these electrons are revolving like a wave. So for example, this is the circular. So in circular path, the electron is moving. The electron is moving the wave nature like this. Okay. So, like that, electron moving around the nucleus in the form of wave అని చెప్తున్నారు. అర్థమవుతుందా? So the wave nature electron can be described by the Schrodinger wave equation three-dimensionally regarding x-axis, y-axis, and z-axis. Okay, how these electrons are revolving around the nucleus three-dimensionally. So for that, he derived a mathematical equation. What is the dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m e minus v into psi by s square. Okay, so that is the Schrodinger wave equation. Okay, so here we have to derive the Schrodinger wave equation. So according to Schrodinger wave equation, so this Schrodinger wave equation can be from fundamental equation. So the fundamental equation, what is fundamental equation? What is fundamental equation from the Planck's from the series? This rho square psi by x square is equal to minus 4 pi square psi by h square by h square. Okay, so this is the fundamental equation. So to derive the Schrodinger wave equation. Schrodinger wave equation. So dou square psi by dou x 4 pi square psi by h square. సో ఒక్కొక్క ఒక్కో రకంగా ఉంటుంది, మీరు కన్ఫ్యూజ్ ఏం కాకండి. రైట్ రైట్. సో హియర్ ఈ పార్ట్ ను మైగ్రేట్ దిస్ పార్ట్ టు లెఫ్ట్ సైడ్, మూవ్ పార్ట్ లెఫ్ట్ సైడ్, సో దట్ విల్ like this. So 4 psi square, so 4 pi square psi by h square is equal to dou square psi by dou x square. Dou square psi by dou x square. So we can write like this. So 1 by sorry lambda square. Sorry. Not h square, lambda square. Sorry. Right. So 4 pi square psi by lambda square is equal to dou square psi by dou x square. And so we can write this equation like this: minus 1 by lambda square is equal to minus 1 by lambda square, 1 by lambda square is equal to ఇది ఆల్రెడీ అయిపోయిందా మీకు? అయిపోయిందా? సో ఈ డెరివేషన్ పార్ట్ డైరెక్ట్ అది టైం వేస్ట్, వేరే స్టార్ట్ చేయాలా? ఇది డెరివేషన్ పార్టే కాబట్టి. సో ఫైనల్లీ వాట్ ఈస్ దట్? దో స్క్వేర్ psi by x square plus దో స్క్వేర్ psi by దో y square plus square psi by దో z square 8 pi square m e minus b by square is equal to 0. So that is the Schrodinger wave equation. సో డెరివేషన్ పార్ట్ లో మన డి బ్రోగ్లీ ఈక్వేషన్ యూజ్ చేస్తాం అండ్ వేరియస్ యూజ్ చేస్తాం. సో కాబట్టి డెరివేషన్ పార్ట్ అనేది ఇట్ ఈస్ నాట్ ఇంపార్టెంట్. ఓకే, అండ్ మెయిన్ గా ఏంటంటే, సో ఆఫ్టర్ దిస్ psi importance of psi and importance of psi square. Okay, what is the importance of psi? Psi means wave function. It means amplitude of the wave. What is psi? Psi is the wave function. Psi means wave function. What is that? It means amplitude of the wave means, so generally the electrons are moving around the nucleus in a wave like this, isn't it? In a wave like, okay, so this is the height of the wave is known as amplitude, or the depth of the wave is known as amplitude. Okay, see this amplitude, this the distance of the wave is known as amplitude, and the depth of the wave is known as also amplitude. Okay, so that is wave function means amplitude of the wave. And here this psi has positive value and negative values. Psi has positive and negative values. So this height will be positive value and depth will be negative value. So in a wave, what is the positive value? The height of the wave is known as positive amplitude, and depth of the wave is known as negative amplitude. So this is the significance of the psi. And what about psi square? What about psi square? Psi square is the probability of density. Probability of density. Probability of density means determine the probability of finding electron maximum around the nucleus. Okay. So what is the psi square? Probability of density. So it determines what? The probability of finding electron. Probability of finding electron is maximum at a point. At a point is known as what? The probability of finding electron is maximum at a point is known as what? దాన్ని ఏమంటాం? Orbital. What is that? Orbital is known as orbital. That point is known as orbital. Around the nucleus is known as orbital. Okay, దాన్ని మనం ఏమంటాం? Orbital అని అంటాం. Right? So sometimes psi square, if psi square value is 0, that means at that point the finding of electron is 0. The probability of finding electron is 0. If psi square is 0, probability of finding electron is also 0. So that indicates nodal plane. So where the probability of finding electron is 0, so that point is known as node or nodal plane antam. Where the probability of finding electron is 0. Okay. So ఎక్కడైతే probability of finding electron 0 ఉంటుందో దాన్ని ఏమంటాం? నోడ్ అంటాం. నోడ్. ఓకే. సో నోడ్ అంటే అప్కమింగ్ క్లాసెస్ లో నోడ్ గురించి క్లియర్ గా చెప్పుకుంటాం. ఓకే. సో దిస్ ఇస్ అబౌట్ ది psi and psi square. ఓకే. అండ్ నెక్స్ట్ మాలిక్యులర్ ఆర్బిటాల్ థియరీ. సో వెరీ వెరీ ఇంపార్టెంట్. మాలిక్యులర్ ఆర్బిటాల్ థియరీ చెప్దాం. సో మాలిక్యులర్ ఆర్బిటాల్ థియరీ, MOT, మాలిక్యులర్ ఆర్బిటాల్ థియరీ. ఓకే. సో దిస్ మాలిక్యులర్ ఆర్బిటాల్ థియరీ was proposed by who? ఎవరు ప్రపోజ్ చేశారు? Hund and Mulliken. The scientist Hund and Mulliken proposed this theory. Okay. Hund and Mulliken proposed molecular orbital theory. So according to molecular orbital theory, a linear combination of atomic orbitals. So that is what LCAO. ఏమంటుందని? LCAO. What is LCAO? Linear combination of atomic orbitals leads to form molecular orbitals. How the molecular orbitals are formed? By the overlapping of atomic orbitals, molecular orbitals are formed. For example, hydrogen plus hydrogen gives rise to H2. Okay. So in hydrogen, what is this is the s orbital of hydrogen, and this is the one electron. Orbitals are combined together. When are combined together, what happened? The molecular orbital is formed. This is molecular orbital, and this is what? Atomic orbital. This is also atomic orbital. Atomic orbitals are combined together, and here the molecular orbitals are formed. సో మాలిక్యూల్ ఎలా ఫామ్ అవుతాయి? Molecules are formed by the combining of the atomic orbitals. By overlapping of the atomic orbitals, molecular orbitals are formed. Molecules are formed by the combination of atoms. Atoms కలిస్తే మాలిక్యూల్స్ ఫామ్ అవుతాయి కదా. సో ఇక్కడ 2 atoms కంబైండ్ అవుతే ఒక మాలిక్యూల్ ఫామ్ అయింది. ఏ మాలిక్యూల్? H2 హైడ్రోజన్ మాలిక్యూల్ ఫామ్ అయింది. ఇక్కడ ఏంటిది? హైడ్రోజన్ ఆటమ్. ఇక్కడ ఏంటి? హైడ్రోజన్ ఆటమ్. 2 atoms కంబైండ్ అవుతే 1 మాలిక్యూల్ అనేది ఫామ్ అవుతుంది. ఇవి ఎలా ఫామ్ అవుతాయి అంటే, సో హియర్ ద అటామిక్ ఆర్బిటల్ ఆఫ్ దిస్ హైడ్రోజన్, atomic orbital of second hydrogen combined together form a molecular orbital. So that is what linear combination of atomic orbitals leads to form the molecular orbitals. Mari, how many molecular orbitals are formed? See, here the number of molecular orbitals is equal to number of atomic orbitals which are combined. Which are combined. అంటే ఏంటి దీని మీనింగ్? సో molecular orbitals are equal to number of molecular orbitals are equal to number of atomic orbitals which are combined. For example, 2 atomic orbitals are combined together. How many molecular orbitals are formed? 2. For example, 4 atomic orbitals are combined together. How many molecular orbitals are formed? 4. Like that. So here the number of molecular orbitals are equal to number of atomic orbitals which are combined. Okay. And for example, A atomic orbital and B atomic orbitals are combined together, and here 2 molecular orbitals are formed. So in that, one is lower energy molecular orbital and another one is higher energy molecular orbital. So the lower energy molecular orbital is known as bonding molecular orbital, and higher energy molecular orbital is known as anti-bonding molecular orbital. So like that, here the 2 atomic orbitals are combined together, and in the molecular orbitals, 2 molecular orbitals are formed. One is lower energetic molecular orbital and another one is the higher energetic molecular orbital. See, energy, example, this is the energy line. Okay, so this is the energy of this atomic orbital. This is the energy level of the second atomic orbital. ఈ రెండు కంబైండ్ అవుతే ఏమవుతున్నాయి? Some molecular orbitals are below the energy of the atomic orbitals. చూడండి, లెవెల్ ఎక్కడ ఉందమ్మా? ఇక్కడ ఉంది. ఈ బాండింగ్ మాలిక్యులర్ ఆర్బిటల్స్ యొక్క ఎనర్జీ లెవెల్ ఎక్కడ ఉంది? కింద ఉంది. సో మీన్స్ హ్యావింగ్ లో ఎనర్జీ. సో ద లో ఎనర్జెటిక్ మాలిక్యులర్ ఆర్బిటల్స్ ఆర్ కాల్డ్ బాండింగ్ మాలిక్యులర్ ఆర్బిటల్స్. సమ్ మాలిక్యులర్ హైయర్ దెన్ ద అటామిక్ ఆర్బిటల్స్. సో ఈ ఎనర్జీ లెవెల్ కంటే ఈ ఎనర్జీ లెవెల్ ఎక్కువ ఉందా తక్కువ ఉందా? ఎక్కువ ఉంది. కాబట్టి హైయర్ ఎనర్జెటిక్ మాలిక్యులర్ ఆర్బిటల్స్ ఆర్ నోన్ యాజ్ యాంటీ బాండింగ్ మాలిక్యులర్ ఆర్బిటల్స్ and lower energetic molecular orbitals are known as bonding molecular orbitals. Like that. So the number of atomic molecular orbitals are equal to number of atomic orbitals which are combined. In this case, how many atomic orbitals are combined? 2. So that here the 2 molecular orbitals are formed. Okay, so one is lower energetic molecular orbital and another one is the higher energetic molecular orbital. And next point, see, so these molecular orbitals are filled by these molecular orbitals are filled by these molecular orbitals are filled by ఎలా ఫిల్ అవుతాయి? filled by some principles. What are they? Some principles. By above principle and Hund's principle, and then Pauli exclusion principle, Pauli's principle. Okay, so these molecular orbitals are filled by the Hund's and Pauli's principle. So these molecular orbitals are filled by the electrons by above Hund's and Pauli's exclusion principle. And next, if number of molecular orbitals, sorry, if number of electrons in a molecule is up to 14, the configuration is different from the number of electrons above 14. Okay, total number of electrons in a molecule 14, suppose up to 14, configuration is like this. Configuration ఎలా ఉంటుంది? Molecular orbital configuration, that is sigma 1s, sigma star 1s. Okay, sigma star 1s. Number of point. ఇదా? ఇదా? If number of electrons in a molecule is up to 14, the configuration ఇలా ఉంటుంది. సో దీని మీద రెండు టాపిక్స్ ఉన్నాయి, 2 టాపిక్స్ ఉన్నాయి. ఏంటి? మాలిక్యులర్ ఎనర్జీ డయాగ్రామ్స్ ఆఫ్ ఆక్సిజన్. ఓకే, కాబట్టి సో అవి అర్థం కావాలంటే ఫస్ట్ ఈ కాన్సెప్ట్ అర్థం కావాలి, మాలిక్యులర్ ఆర్బిటాల్ కాన్సెప్ట్ అర్థం కావాలి. సో ఇఫ్ నంబర్ ఆఫ్ ఎలక్ట్రాన్స్ ఇన్ ఏ మాలిక్యూల్, ఇఫ్ నంబర్ ఆఫ్ in a molecule is up to 14 electrons, the configuration is like this: sigma 1s, sigma star 1s. Okay, sigma 2s, sigma star 2s, sigma star 2s. So stars are what? Stars ante enti? Anti-bonding molecular orbitals. So bonding molecular orbitals, anti-bonding molecular orbitals, anti-bonding molecular orbitals are denoted by star. Okay, sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. And next to pi 2px is equal to pi 2py. Pi 2px is equal to pi 2py. And sigma 2pz, sigma 2pz. And then, so pi star 2px, pi star 2px is equal to pi star 2py and sigma star 2pz. So this is the molecular orbital electronic configuration of 14 electrons. Here the energy order of molecules vary here only. So if the number of electrons are above 14, the configuration in the energy order of this pi star 2px and pi star 2py. Okay, so let's see. So up to 14 electrons, this is the molecular electronic configuration. So for example, so here 2, 2, 2, 2. So how many? Up to this 10. Okay, and next to 12, 13 and 14. 13 and 14. So up to 14, so you have to follow this molecular orbital electronic configuration. If above 14, the configuration is different. So like so if above 14, if the number of electrons are above 14, the configuration is like this. So up to this same. So up to this, the energy order of the molecule is same, and here the molecular orbital energy vary here only. Okay, so that is sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Okay na? So pi 2px is equal to pi 2py and sigma 2pz, and here the energy order change like this. Here sigma star pi star 2py. So this is the molecular orbital energy diagram of molecules if electrons are above 14. Okay, 14 కంటే ఎక్కువగా ఉంటే, so you have to follow this molecular orbital configuration. Okay, electronic configuration. If 14 above ఉంటే ఇది ఫాలో కావాలి, బిలో ఉంటే ఇది ఫాలో కావాలి. సో ఇక్కడ డిఫరెన్స్ ఎక్కడ ఉంది? వెర్ ఇస్ ద డిఫరెన్స్? సో దానికి దీనికి డిఫరెన్స్ ఎక్కడ? సో అప్ టు హియర్ ఇక్కడ వరకు సేమే, బట్ ఇక్కడ చేంజ్ అవుతుంది. సిగ్మా energy are lower than the 5 star 2p 5 star 2py. That is the difference. చూడండి, సిగ్మా స్టార్ 2pz ముందుకు వస్తుంది అంటే ఎనర్జీ అనేది తగ్గిపోతుంది. సో ద ఎనర్జీ ఆఫ్ సిగ్మా స్టార్ 2pz ఈజ్ లోయర్ దెన్ ద 5 స్టార్ 2px and 5 star 2py. That is the difference. Okay, you have to follow this molecular orbital configuration. Based on that, you can draw the molecular orbital energy diagrams. Okay, so one example is that is up to 14 electrons, and another example is above 14 electrons. We have two examples. One is oxygen and carbon monoxide. Okay, మనకు సిలబస్ లో రెండే ఉన్నాయి. వేరే కూడా ఇస్తున్నారా? అవే అడుగుతున్నారు ఎగ్జామ్ లో. సో ఏది ఇచ్చినా చేసేటట్టుగా మనం అనుకోవాలి. ఒక 2-3 ఎగ్జాంపుల్స్ చూద్దాం. రైట్, దిస్ ఈస్ ద మాలిక్యులర్ ఆర్బిటాల్ ఎనర్జీ, molecular orbital theory. So once again, see, so this molecular orbital theory was proposed by Kunz and Mulliken. According to molecular orbital theory, the linear combination of atomic orbitals leads to formation of the molecular orbital. And here the number of molecular orbitals are equal to atomic orbitals which are combined. So here two atomic orbitals, if atomic orbitals are combined together, mainly two types of molecular orbitals are formed. Bonding molecular orbital, that is lower energetic molecular orbital, and another one is the higher energetic molecular orbital, anti-bonding molecular orbital. And these molecular orbitals are filled by the electrons on the basis of above Kunz and Pauli's exclusion principle. And then if number of electrons in a molecule is up to 14 electrons, this is the configuration. And if number of electrons are above 14 electrons, this is the configuration. And ఇంకొకటి ఉంది, ఇంకా కొన్ని పాయింట్స్ ఉన్నాయి. సో ఏంటంటే, so after this you can calculate bond order. So what is bond order? Bond order means number of bonding electrons minus number of anti-bonding electrons by 2. So by using this formula, you can calculate the bond order of the any molecule. Okay, and next to also calculate the magnetic character. Okay. If electrons are paired, if electrons says diamagnetic in nature, if electrons are molecule possess diamagnetic nature. What is the meaning of diamagnetic nature? What is the meaning of diamagnetic? So diamagnetic means that if electrons are paired in the molecule or orbitals, that a molecule possesses diamagnetic in nature. That means that molecule repelled by the magnet. Diamagnetic means that molecule is repelled by the magnetic. And then paramagnetic means that molecule is attracted by the magnet. If the molecule is attracted by the magnetic, it is known as paramagnetic. So paramagnetic molecule can be explained by the molecular theory. So if electrons are alone in a molecule, electrons are alone, that molecule possess which nature? Possess paramagnetic nature. Possess the paramagnetic nature. So this is about the magnetic nature of the molecule. So that nature can be explained by the MOT, orbital theory. So if the molecules are having paired electrons, that molecule possess diamagnetic nature. If the molecule has lone pair of electrons or electrons are alone, that molecule possesses paramagnetic nature. Paramagnetic nature means that molecule is attracted by the magnet. So these are the various points which are covered in the molecular orbital theory. So based on that, we have to draw some energy diagrams of the homo and heteroatomic molecules. Homoatomic molecules and heteroatomic molecules. Homo means homoatomic molecules. Tell me examples of homoatomic molecules. Homoatomic molecules means that molecule has same atoms. If the molecule has same atoms, is known as homoatomic molecules. If the molecule has heteroatomic molecules. So, ఒకటి homoatomic molecule example and ఇంకొకటి heteroatomic molecule example చూద్దాం. Right. Molecular orbital energy diagrams of homoatomic molecules. Homoatomic molecules. Molecular energy diagrams of homoatomic molecules. So, what are they? Homoatomic molecules? Nitrogen, oxygen, so fluorine, like that. Okay. In our syllabus, we have only this molecule, oxygen molecule. రెండు N2 కూడా ఉందా? నైట్రోజన్ కూడా ఉందా? ఆక్సిజన్ ఉందా? మేడం చెప్పారు కానీ సిలబస్ లో అయితే N2 ఉందా? అండ్ కార్బన్ మోనాక్సైడ్. N2 ఉంది, O2 ఉంది. రైట్. సో నైట్రోజన్ అండ్ ఆక్సిజన్. సో చూద్దాం, రెండు చూద్దాం. సో ఫస్ట్ నైట్రోజన్ మాలిక్యూల్. Nitrogen molecule. In nitrogen, each nitrogen has how many electrons? 7. What is the configuration? 1s2, 2s2, 2p3. 1s2, 2s2, 2p3. So that in the nitrogen, how many electrons? Nitrogen molecule, 14 electrons are there. Okay. So these 14 electrons are present in the molecule by the linear combination of nitrogen atomic orbitals. Okay. How many electrons are there? 7 electrons are there. 1s2, 2s2, 2p3, and also 1s2, 2s2, 2p3. The nitrogen molecular orbitals are formed by the combination of linear combination of atomic orbitals of each nitrogen. Vinandi. These nitrogen molecular orbitals are formed by the linear combination of atomic orbitals of each nitrogen. 1s2, 1s2, and 2s2, 2s2, 2p3, 2p3. So like that, they are overlapping with each other. Overlapping with each other. So let's see the diagram. See, this is energy, and this is the energy line of the another nitrogen atom, second nitrogen atom. Okay, so first 1s2, 1s2. Okay, 1s2 atomic orbital of one nitrogen combined with the 1s2 atomic orbital of second nitrogen. So orbital 1s2 and this is 1s2 in the atomic orbitals. What are these? 1s2, 1s2 are the atomic orbitals. So if these two atomic orbitals linearly combined, how many molecular orbitals are formed? Any form aitama? So how many atomic orbitals are there? One nitrogen and second another nitrogen. How many atomic orbitals? So 1s అనేది ఏంటిదమ్మా? 1s అనేది ఏంటి? 2s, 2s also how many? 2. 2s లో 2 ఉంటాయా? That second 2 represents what? Second orbit. The 2 represent what? Second orbit. 1 represent what? First orbit. In the first orbit, s orbital, 1 atomic orbital, s orbital. Okay, 1 atomic orbital of 1 nitrogen. Here 1s orbital of second nitrogen are linearly combined each other and form 2 molecular orbitals. Molecular orbitals. This molecular orbital and energetic molecular orbital is molecular orbital. Okay, so lower energetic and higher energetic molecular orbitals. So by linear combination of atomic orbitals, here the sigma bond is formed. Okay, sigma 1s, and here sigma 1s, sigma 1s and sigma star. Right. So how many total electrons are there? And ఓకే, ఈ డయాగ్రామ్ అయిపోయిన తర్వాత బ్రేక్ ఇద్దాం. ఇప్పుడే స్టార్ట్ కదా చేసింది, మరి అప్పుడే బ్రేకా? ఓకే, 2:30కి ఇద్దాం, టెన్షన్ పడకండి. ఓకేనా? రైట్. సో హౌ మెనీ ఎలక్ట్రాన్స్? 2 and 2. So these 4 electrons, the molecular orbitals on the basis of above Kunz and Pauli's principle. So the uh, electrons by lower energy molecular orbital followed higher energy molecular orbital. What is the principle? According to which principle the electrons are filled for lower energy level first and followed by the higher energy level? Principle. Based on above principle, electrons are filled at lower energy molecular orbital followed by the higher energy molecular orbital, like this. Okay, and next 1s2 1s2 and next 2s2 2s2. So here the 2s2 orbital of 1 nitrogen and 2s2 orbital of second nitrogen. Okay, second nitrogen atoms are similarly combined, and here 2 molecular orbitals are formed: lower energetic molecular orbital, molecular orbital, lower energetic molecular orbital and higher energetic molecular orbital. So here the linear combination of atomic orbital leads to formation of sigma bond, sigma 2s and sigma star 2s. Okay, total how many electrons? 4 electrons. The 2 electrons are filled first at lower energetic molecular orbital and followed by the higher energetic molecular orbital. Sigma 1s2, sigma star 2s2, sigma star 2s2, and next P3 and 2p3. So here how many p orbitals are present? 3. So 3, right? 3 plus 3. Many molecular orbitals? 6 molecular orbitals are formed. So in the 6 molecular orbitals, 3 are lower energetic molecular orbital and 3 are higher energetic molecular orbitals. 3 are higher energetic molecular orbitals. Okay, so in the bottom 2px, pi 2px and pi 2py, and here sigma 2pz, and here pi star 2px, pi star 2px and pi star 2py, and here sigma star 2pz. So this is the order. This is the molecular orbital order. So total how many? We are 3 electrons are present in each are there, and these 6 electrons by above Kunz and Pauli's exclusion principle. So ఎలా ఫిల్అప్ చేయాలి ఎవరైనా చెప్తారు అది ఫస్ట్ lower energetic same energetic molecular orbitals are there. How many? Two. So in that, one electron, second electron, third electron. What is the rule? What is that rule? ఏంటది? Kunz rule. The pairing of electrons takes place. ఎలా pair అవుతుంది? So each orbital, the pairing of electron takes place after each orbital filled by one electron. The pairing of electrons takes place after each orbital filled by one electron. Okay. So ఇక్కడ ఒక ఎలక్ట్రాన్ fill up అయిన తర్వాత third electron paired with and then fourth electron is paired with second electron. Four electrons are completed. And then for the above principle, lower energetic molecular orbitals are filled. And then remains two electrons. That two electrons are filled in higher energetic molecular orbitals. So total 6 electrons are filled at lower energetic molecular orbitals. Okay. And then write the configuration. Write the molecular orbital electronic configuration. ఎలా రాయాలి? So ఇక్కడ how many electrons are present in the pi 2px? 2. Pi 2py? 2. Sigma 2pz? 2. Okay. So write the molecular orbital electronic configuration. So చెప్పండి sigma molecular orbital electronic configuration, MOEC. Okay. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Okay. And sigma 2pz2. So this is the molecular orbital electronic configuration. And next to bond order. Next point ఏంటి? Bond order. So bond order is, what is the formula? Number of bonding electrons minus number of anti-bonding electrons by 2. So how many bonding electrons are there? ఎవరైనా ఎందుకు చెప్పమ్మా? How many bonding electrons are there? నువ్వే. So count number of bonding electrons. Number of bonding electrons. So what are bonding molecular orbitals? 8. 2 plus 2. 4. 4 plus 6. Total 10. 10 minus anti-bonding electrons. 2 plus 2. 4. 10 minus 4 by 2 means 3. So that means, sit down. That means 3 bonds are binds the atoms. So bond order 3 means that atoms are in the molecule are bind by 3 bonds. 3 bonds. That's why the nitrogen molecule structure is N triple bond N ఉంటుంది. And then magnetic nature. What is the magnetic nature? Magnetic nature is it diamagnetic or paramagnetic? So you have to see the electrons in outermost molecular orbitals. Outermost molecular orbitals లో electrons ని మీరు అబ్జర్వ్ చేయాలి. outermost molecular orbitals ఏంటివి? outermost means last ఏంటివి? pi 2px2, pi 2py2 and sigma 2pz. So how the electrons are in molecular orbitals? Are these electrons are paired or unpaired? Paired. So that this nitrogen molecule possess diamagnetic nature. Nitrogen molecule possess diamagnetic in nature due to why? Diamagnetic nature due to presence of paired electrons. Due to presence of paired electrons. Okay, due to presence of paired electrons. Okay, this is the molecular orbital energy diagram of the hydrogen molecule. So next to similarly oxygen molecule. Oxygen molecule. So can you draw oxygen molecule energy diagrams? So how many electrons are present in the oxygen molecule? How many? 16. So that you have to change energy order of the molecular orbitals. ఓకే ఎక్కడ చేంజ్ అవుతుంది ఏడా ఇక్కడ ఏది పై 2px పై 2py ఆర్ moves to higher energy and sigma 2pz moves to lower energy. ఓకే లోయర్ ఎనర్జెటిక్ ఆర్బిటాల్ కు సిగ్మా 2pz వస్తుంది. హైయర్ ఎనర్జెటిక్ మాలిక్యులర్ ఆర్బిటాల్స్ కి పై 2py మూవ్ అవుతాయి. ఓకే సో చూద్దాం. సో అది కంప్లీట్ అయిన తర్వాత ఇద్దామా బ్రేక్. ఓకే సో ఆక్సిజన్ మాలిక్యూల్ కూడా కంప్లీట్ చేసుకుంటే బ్రేక్ ఇద్దాం. ఓకేనా రైట్. ఆక్సిజన్ 16 electrons are present. So oxygen molecule is formed by the combination of oxygen atom and oxygen atom. Oxygen atom and oxygen atom leads to form the oxygen molecule. Okay, so each how many electrons? 8 electrons. 1s2, 2s2, 2p4, and here also 1s2, 2s2, 2p4. So here 1s2, 1s2, 2s2, 2s2, 2p4 are nearly combined together and form the molecular orbitals. So the energy line or the energy line of one oxygen and another energy of the second oxygen. Okay, second oxygen. So like this. Okay, first two 1s orbital are linearly combined together. Like this. Okay, 1s2 and here 1s2. So 2 electrons, and these two atomic orbitals are linearly combined together and forms 2 molecular orbitals like this. Okay, so one is the lower energy and another one is the higher energy. Sigma 1s2 and here sigma star 1s2, 2 and 2. Okay, and next to 2s2 molecular orbital. So here 2s2 atomic orbital of one oxygen and 2s2 atomic orbital of second oxygen are linearly combined together like this. Okay, so this is what sigma 2s2 and this is sigma star 2s2, 2 electrons and 2 electrons. Okay, and next to we go difference. So orbitals present, three atomic orbitals are present, and so these three are combined together and form a 3 bonding molecular orbitals and 3 anti-bonding molecular orbitals. 3 anti-bonding molecular orbitals are formed. So here the energy order, so the sigma 2pz energy order lower than the pi 2px and pi 2py. So this is the difference. Okay, this is what pi 2px and this is pi 2py, and here same pi star 2px and this is pi star 2py, and here pi sigma star 2pz. Okay, and fill the electrons. So how many electrons are there? Totally 4 electrons, and here 4 electrons, and total how many electrons? 8 electrons, and these 8 electrons are filled accordingly Aufbau principle. So at a lower energy, 2 electrons, and third electron in this orbital, fourth electron in this orbital, and fifth electron and sixth electrons. Okay, so remaining 2 electrons. So the 2 electrons are jumps to higher energetic molecular orbital. So in this one and in this one. So don't add each other. So according to Hund's principle, the electrons are filled one one electron each. Okay, the atomic orbitals are filled by 1 electron each, and then pairing takes place. Okay, so up to 8 electrons, total 8 electrons are there కాబట్టి సో ఇక్కడ వరకు 8 electrons fill up అయిపోయినాయి. So see the electrons in the molecular orbitals, how they are. Are these electrons are paired or unpaired? Unpaired. Unpaired. So that these molecule, oxygen molecules possess which nature? Paramagnetic or diamagnetic? Paramagnetic nature. Okay. So write the configuration: sigma 1s2, sigma star, molecular orbital electronic configuration. Sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, sigma 2pz2, and then sigma 2pz2, and then pi 2px2 is equal to pi 2py2, and pi star 2px1 is equal to pi star 2py1. Okay, see, this is the molecular orbital energy configuration. And next to bond order. So bond order is Nb minus Na by 2. So how many bonding electrons? 2 to 4 plus 6, 10. So 10 electrons in the bonding molecular orbital. And how many in anti-bonding? 2, 2, and 2. How many? Total 6. 10 minus 6 by 2 and a 2. So that the oxygen molecule exists like this. Oxygen molecule exists to as O double bond O. O double bond O. Two bond order kabatti. So the two bonds binds the two atoms in a oxygen molecule. And then magnetic nature. So magnetic nature of the molecule is paramagnetic. It is a paramagnetic in nature due to presence of presence of what? Presence of unpaired electrons. Unpaired electrons. Due to unpaired electrons. So this is what oxygen molecular energy diagram. Okay. Next to carbon monoxide. Okay. How many electrons are present in monoxide? Okay. Break తీసుకుంటారా? Right. Break up to 6 వరగా. 3. Break up. Right. Enjoy. Up to 4 అంటే ఇప్పుడు వెళ్ళిపోయి. Right. ఎస్. సో అందరూ ఒకసారి ఒక 1 అవర్ వింటే మనం సెషన్ క్లోజ్ చేయొచ్చు. ఓకే, మాక్సిమం 1 అవర్ కొద్దిగా ఓపిక తోటి వినండి. సో మనకు ఇంకా ఒక మాలిక్యూల్ ఉంది, అండ్ తర్వాత 5 మాలిక్యులర్ ఆర్బిటాల్ థియరీ ఉంది. 5 మాలిక్యులర్ ఆర్బిటాల్ థియరీ అండ్ one heteroatomic molecule in a molecular orbital energy diagram. So how can you draw the molecular orbital energy diagram of heteroatomic molecule? So close చేయండి ఫోన్, క్లోజ్ చేయండి ఒక 1 అవర్. 1 అవర్ వాటర్ తాగండి, తాగి ఒకసారి ఒక 1 అవర్ వినండి. రైట్. సో molecular orbital energy diagram molecule, molecular orbital energy diagram heteroatomic molecules, heteroatomic molecule. So example carbon monoxide, carbon monoxide. So in this molecule two types of atoms, one is carbon and the second one is the oxygen. So two different atoms, so that it is heteroatomic molecule, heteroatomic molecule, two types of atoms. So పక్కన వాళ్ళను పడుకున్న వాళ్ళని లేపండి. కొంచెం పడుకోకండి. ఫోన్ ఆపరేటింగ్, మొబైల్ ఆపరేటింగ్ స్టాప్ చేయండి. ఒక 1 అవర్ ఓపికతో చూడండి. See here, in this two atoms are there, two types of atoms are there. In the carbon, how many electrons are there? 1s2, 2s2, 2p2. 1s2, 2s2, 2p2. What is the atomic number of carbon? 6. 6 is the atomic number of carbon. So in that 6 electrons present. And oxygen 1s2, 2s2, 2p4. So during formation of molecule, to our overlap with the 2s orbital of oxygen. 2p2 orbital of carbon overlap with the 2p4 orbital of oxygen. So the total number of electrons, the total number of electrons in the carbon monoxide, how many? 6 plus 8, 14. 14 electrons. So that we have to follow up to 14 electron configuration or above 14 electron configuration. Up to 14. ఎందుకంటే 14 electrons ఉన్నాయి కాబట్టి, so the configuration is you have to follow 14 electronic configuration. The order also like that. Okay. So see, draw the energy of carbon atom and energy of oxygen atom. Okay. Left side carbon atom and right side oxygen atom. This is the carbon and this is what? Oxygen atom. Right. So 1s2 orbital, 1s2 orbital of carbon overlap with 1s2 orbital of oxygen. Okay. 1s2 and 1s2. Okay. So these atomic orbitals are linearly combined together and form two molecular orbitals. Two molecular orbitals. One is the bonding molecular orbital, that is sigma 1s2, and this is sigma star 1s2. So total how many electrons in atomic orbitals? 4. And these 4 electrons are the orbitals on the basis of above principle. And next, 2s2 orbital of 2s2 orbital of oxygen. 2s orbital of oxygen are linearly overlap with each other and form two molecular orbitals. So in that one is sigma 2s2 and sigma star 2s2. Sigma star 2s2. Okay. And next, here we have to follow the two molecular configuration. And here also, okay, this is oxygen, and here 2p 2, and here 2p 4. Okay. So in this 2 electrons, in these 4 electrons, like this. Okay, 4 electrons. And these atomic orbitals are linearly together and form 3 bonding molecular orbitals and 3 antibonding molecular orbitals. Order- See, what are these? These are pi 2px and pi 2py. This is sigma 2pz. And this one pi star 2px, pi star y. Pi star px, pi star py. And this one sigma star 2pz. So how many electrons are present in carbon and oxygen? Here 2 and 4, totally 6. So 1, 2, 3, 4, 5, and 6. So like that, total 6 electrons lower in molecular orbitals only. Configuration is molecular orbital electronic configuration. Molecular orbital electronic configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, and then pi 2px2 is equal to pi 2py2 and sigma 2pz2. Okay, so this is the molecular electronic configuration of the carbon monoxide. And then bond order. So bond order of the molecule is Nb minus Na by 2. So how many Nb electrons are there? 10. 2 plus 2, 4 plus 6, 10. So 10 electrons minus antibonding electrons and star electrons. 2 plus 2, 4. And 10 minus 4 by 2 gives 3. So that the structure of the molecule is C triple bond O. The C triple bond O. Okay. So this is the bond order. And then magnetic nature, magnetic property is paramagnetic or diamagnetic. So carbon monoxide is a diamagnetic. Enduku all the electrons in the all the electrons in the molecular valency molecular orbitals are paired. Carbon monoxide is a diamagnetic in nature. This is about the a molecular orbital energy diagram of heteroatomic molecules. So this is the bond order. See, so bond order shortcutly మనం చెప్పొచ్చు. So if the number of electrons are 14, so the bond order is 3. If the number of electrons are 13, the bond order is 2.5, 12, 2, 11, 1.5, 15, 2.5, 16, 2.0, 17, 1.5. Like we can also say direct molecules on the basis of number of electrons. So number of electrons present in the molecule. So this is the scale. This is the center of the scale, and above. So each decreases 1 electron. The bond order decreases to 0.5. Okay, increases one electron. Bond order decreases to 0.5. బాండ్ ఆర్డర్ అనేది డిక్రీజ్ అవుతుంది. దిస్ ఇస్ షార్ట్ కట్. షార్ట్ లో మనం బాండ్ ఆర్డర్ ఈ విధంగా డైరెక్ట్లీ వి కెన్ సే. సో దిస్ ఇస్ అబౌట్ ది మాలిక్యులర్ ఎనర్జీ డయాగ్రామ్ ఆఫ్ హెటరో అటామిక్ మాలిక్యూల్. అండ్ నెక్స్ట్ పై మాలిక్యులర్ ఆర్బిటాల్ థియరీ. ఓకే, పై మాలిక్యులర్ ఆర్బిటాల్ థియరీ నోట్ చేసుకుంటారు. So next to molecular orbital theory. Molecular orbital theory. So here pi bond is formed by the overlapping of lateral overlapping of p orbitals. Generally, pi bond is formed by the over lateral overlapping of orbital. It is it is formed by lateral overlapping or sideways overlapping of p orbital. Overlapping of p orbital. Generally, pi bond ఎలా ఫామ్ అవుతుంది? By lateral overlapping of the p orbital only, not d orbital, not s orbital. So the p orbital overlapping, the lateral overlapping of p orbitals to the formation of pi bond. P orbital is equal. Okay. So here, these are p orbital. This is p orbital. Okay. So in well, positive lobe. So the positive lobe is this lobe is called positive lobe, positive lobe, and this lobe is called negative lobe. The p orbital has two lobes. One is positive lobe, which is above the plane, and one is negative plane. So one is negative lobe, which is below the plane. The lobe which is above is known as positive lobe. The lobe which is below the plane is known as negative. Okay. And here, bones happy andama. Okay. So by opening of orbitals, by overlapping p orbitals leads to the formation of pi bond. So this is the p orbital and this is another p orbital. These p orbitals are overlapping sideways. So like this, here pi bond is formed. Okay. So here this positive lobe overlap with the positive lobe and negative lobe overlap with the negative lobe. So this type of overlapping is known as constructive overlapping. Constructive overlapping. Okay. So constructive overlapping leads to the formation of pi bond. Okay. So ఇలా ఓవర్లాప్ అవడం ద్వారా మనం ఫామ్ అవుతుంది. For example, if p orbitals are overlapped like this. Okay, so this is p orbital and this is another p orbital, isn't it? So this is the positive lobe and this is the negative lobe. So if overlap like this, ఇలా ఓవర్లాప్ అయింది అనుకోండి. సో ఇలా ఓవర్లాప్ అయితే ఏమవుతుంది? దెర్ ఇస్ ఏ ఇలా ఓవర్లాప్ అవుతుంది పాజిటివ్ అండ్ నెగటివ్. సో జీరో, one positive and one negative leads to zero overlapping antam. So there is no finding of electrons that leads to node, that leads to the node. అర్థమవుతుందా? By overlapping like this, by overlapping positive lobe and negative lobe. సో ఇలా పాజిటివ్ లోబ్ నెగటివ్ లోబ్ ఓవర్లాప్ అవ్వడం ద్వారా మనకి ఏమవుతుంది? సో నోడ్ ఫామ్ అవుతుంది. there is no finding the electrons. What is node? Nodal plane or node. There the probability of finding electron is 0. Okay, there is no at that area you can't find the electrons. Okay, that areas are known as node. వాటిని మనం ఏమంటాం? నోడ్స్ అంటాం. ఓకే, వాటినే నోడ్స్ అంటాం. సో ఎలా ఏర్పడతాయి నోడ్స్? ఓవర్లాపింగ్ ఆఫ్ వన్ పాజిటివ్ లోబ్ అండ్ negative lobe. Keep in mind. So the nodes are formed by the overlapping of the positive lobe of p orbital and negative lobe of another p orbital. Okay, leads to formation of node. So ఇక్కడ కూడా negative, sorry. Okay, ఇది negative lobe and this is positive lobe. Sorry. Like this. So ఇలా over ద్వారా, so that leads to nodal plane. So ఈ విధంగా pi bond are formed by pi bonds are formed by the lateral overlapping of the p orbitals. Okay, so we have two molecules. One is 1,3 butadiene and another one is benzene. 1,3 butadiene and second one is the benzene. When you draw 5 molecular orbitals in the 1,3 butadiene and benzene. See, 1,3 butadiene, 5 molecular orbitals. Okay, 5 molecular orbitals in 1,3 okay, 1,3 butadiene. So what is the structure of 1,3 butadiene? Buto means how many carbons? 4. Diene. How many ins? 2 ins. They are arranged alternatively. CH2 double bond CH 1,3, isn't it? So this is the 1,3 butadiene. How many pi bonds are there? How many pi bonds are there? 2 pi bonds are there, and 1 pi bond, and here another pi bond, right? So generally here the pi bond is formed by oh, the finger and similarly here this carbon also p orbital, and this carbon has p orbital. By overlapping of like this pi bond is formed. See here has two double bonds or two pi bonds, pi bonds which are formed by lateral overlapping of lateral overlapping of unde p orbital. Okay, so in pi bond formation, how many p orbitals are involved? Orbitals are involved in the pi bond formation. So here two pi bonds are there. So that how many p orbitals are involved? 4. 4 p orbitals involved in the 4 p orbitals are involved in the pi bond formation. Involved in pi bond formation. So how many 5 molecular orbitals are formed? Right. So number of 5 molecular orbitals are number of atomic orbitals. Number of p atomic orbitals which are unhybridized. So generally pi bond is formed by unhybridized p orbital. Antegama. So pi bond is formed by unhybridized p orbital. So here 4 p orbitals formation, pi bond formation, right? So that the number of 5 molecular orbitals is equal to the number of 5 molecular orbitals equal to the number of 5 molecular orbitals equal to number of unhybridized p orbitals. Number of p unhybridized p orbitals. Number of 5 molecular orbitals is equal to number of unhybridized orbitals. So in 1,3 butadiene, how many unhybridized p orbitals? So each carbon has one unhybridized p orbital. Like every carbon has one unhybridized p orbital. So that how many molecular orbitals are formed? How many pi molecular orbitals are formed? 4. So pi molecular orbitals are formed. 4 pi molecular orbitals are formed. Molecular orbitals are formed. What are they? Formed. They are ఏంటవి? They are pi 1. So in these 4, 2 are bonding molecular orbitals and 2 are 4 molecular orbitals are formed. 4 molecular orbitals are formed. In that 2 are bonding and 2 are anti-bonding. Okay, 2 are bonding and 2 are bonding. So let's draw the pi molecular orbitals 1, 3. Okay, ఎలా డ్రా చేయాలి? So and number of nodes. Number of nodes is the number of nodes is equal to number of nodes is equal to so number of pi molecule minus 1 for the planar structure. Planar structure only you can follow formula. The number of pi molecule minus 1. For example, how many nodes are possible? What is the number of molecular 1? 1 minus 1, 0. For pi 1, how many nodes? 0. For pi 2, 2 minus 1. 2 minus 1 is equal to 1. For pi 3 star, 3 minus 1, 2. For pi 4 star, 4 minus 1, 3. That number of nodes maintained in the pi molecular orbital of 1, 3 butadiene. By maintaining nodes, you can draw the pi molecular orbital diagram of the 1, 3 butadiene. You can draw by maintaining number of nodes. By maintaining the theoretical part of 1, 3 butadiene and next energy diagram. డ్రా చేయాలి చూద్దాం అయిపోయింది ఇది సో ఎనర్జీ డయాగ్రామ్ ఆఫ్ diagram of the pi molecular energy diagram. Pi molecular energy diagram of 1, 3 butadiene. See, so this is the energy line. Energy line. Okay. So how many molecular orbitals are present in the 1, 3 butadiene? 4. First one is pi 1 molecular orbital, pi 2, pi 3, pi 4. So pi 1. So in the pi 1, so that is lower energetic molecular orbital. So in the pi 1, draw the 4 p orbitals like this. 4 p orbitals. Right. So this is what pi 1 molecular orbital. How many nodes? 0. How many? 0. So that 0 nodes మెయింటైన్ చేయాలి. 0 nodes మెయింటైన్ చేయాలంటే there is no destructive overlapping. There is positive overlapping. అంటే ఏంటి? all signs are upside. All same sides are upside like this. All positive signs upside. Okay, there is no node. So kabatti node em లేదు కాబట్టి అన్ని పాజిటివ్ సైన్స్ పైకి రాయాలి. ఓకే, అండ్ నెక్స్ట్ 5 2 5 2 మాలిక్యులర్ ఆర్బిటాల్. సో 5 2 ఫస్ట్ ఈ 4 p ఆర్బిటాల్స్ డ్రా చేయండి అండ్ మెయింటైన్ వన్ నోడ్. మెయింటైన్ వన్ నోడ్. దిస్ ఇస్ 5 2 అండ్ హౌ మెనీ నోడ్స్? సో ఎక్కడైనా మెయింటైన్ చేయొచ్చు, మీ ఇష్టం, ఎక్కడైనా మెయింటైన్ చేయొచ్చు. సో ఫర్ ఎగ్జాంపుల్ ఇన్ బిట్వీన్ దీస్ 2 p ఆర్బిటాల్స్ యూ హ్యావ్ టు మెయింటైన్ వన్ నోడ్. కాబట్టి సైన్స్ ఎలా వస్తాయి? దిస్ ఇస్ పాజిటివ్ సైన్, దిస్ ఇస్ పాజిటివ్ సైన్, అండ్ హియర్ ఇక్కడ ఏముండాలి? నెగటివ్ సైన్, అండ్ హియర్ negative sign. Okay, here negative sign like this. Okay, so by maintaining like this, this is the one node. సో ఈ విధంగా వన్ నోడ్ ఉంటే, సో మీతో ఇక్కడ నోడ్ ఉందా? నోడ్ లేదు కాబట్టి సేమ్ సైన్ మెయింటైన్ చేయాలి. నోడ్ ఉంటే ఆపోజిట్ సైన్ ఓవర్లాప్, ఇలా ఓవర్లాప్ అన్నమాట. సో మిగతా మనం లేబులింగ్ చేయాల్సిన అవసరం లేదు. ఓకే, సో ఇక్కడ ప్లస్ మైనస్ మధ్య ఓవర్లాపింగ్, రైట్? అండ్ నెక్స్ట్ 5 3 molecular orbitals are formed like this. Okay, so pi 3. So pi 3, in pi 3 how many nodes are present? 2. So 2 nodes రాయాలి, 2 nodes డ్రా చేయాలి. 2 nodes డ్రా చేయాలంటే సో ఆల్రెడీ ఇన్ బిట్వీన్ 2 and 3 మధ్యలో ఒక నోడ్, అండ్ యూ కెన్ డ్రా లెఫ్ట్ సైడ్ ఆర్ రైట్ సైడ్. యూ కెన్ డ్రా ఐదర్ లెఫ్ట్ సైడ్ ఆర్ రైట్ సైడ్. ఫర్ ఎగ్జాంపుల్ లెఫ్ట్ సైడే డ్రా చేద్దాం అనుకుందాం. లెఫ్ట్ సైడ్ డ్రా చేద్దాం. సో ఇక్కడ ఏమొస్తుంది? ప్లస్. ఇక్కడ ఏమొస్తుంది? మైనస్. ఇక్కడ ఏమొస్తుంది? ప్లస్. అండ్ ఇక్కడ ఏమొస్తుంది? ప్లస్. సో ఆల్టర్నేటివ్ ప్లస్ మైనస్ ప్లస్. ఓకే, అండ్ హియర్ దెర్ ఇస్ నో నోడ్ కాబట్టి ప్లస్ ప్లస్. ఓకే, సో లైక్ దట్. దెన్ సో లేదా దీన్ని షేడ్ చేయండి. షేడ్, యూ కెన్ ఆల్సో షేడ్ వన్ లోబ్ లైక్ దిస్. ఓకే, సో ఇలా షేడ్ కూడా చేయొచ్చు. ఇట్లా ఆపోజిట్ ఉంటే నోడ్ అనమాట, అపోజిట్ ఉంటే నోడ్. అండ్ ఇక్కడ కూడా నెక్స్ట్ node, next to molecular, you have to maintain nodes. So that is 5 4 3 nodes. So కాబట్టి సో ఆల్టర్నేటివ్ గా షేర్ చేసుకుంటూ రావాలి. ఆల్టర్నేట్. సో వన్ ఈజ్ అప్ అండ్ వన్ ఈజ్ డౌన్, అండ్ వన్ ఈజ్ అప్ అండ్ వన్ ఈజ్ డౌన్. ఆల్టర్నేటివ్. ఓకే, సో లైక్ దట్ వీ కెన్ మెయింటైన్ 3 nodes. 3 nodes ను ఈ విధంగా మెయింటైన్ చేయొచ్చు. ఓకే, సో హియర్ వన్ నోడ్, and this is the second node, and this is third node. So in this, pi 1 and pi 2 are the bonding molecular orbitals, and pi 3 star, pi 4 star are the molecular orbitals. Okay, and see Total, how many electrons present in the 1, 3 chain? How many? 1, 3 but how many? 4. ఎన్ని ఉన్నాయమ్మా? ఎన్ని బాండ్స్ ఉన్నాయి? ఎన్ని pi bonds ఉన్నాయి? 2 pi bonds. How many pi bonds are present in the 1? 2. Then how many pi electrons? 4. Each bond 2 electrons. The pi electrons are 4. So you have to fill the 4 electrons. 4 electrons accordingly above principle. Okay. So at this lower energy molecular orbital, and this is the next to energy level molecular orbital. Next to energy level molecular orbital. See, the total 4 electrons, here 2 and then 2. Okay, and here 0. So here homo means homo lumo, highest occupied molecular orbital, and lumo, lowest unoccupied molecular orbital. So this is what homo, this is anti, this is one homo means highest occupied molecular orbitals are how many? This is the occupied molecular orbital with electrons. This is also occupied molecular orbital. So in these two, which is higher one, higher energy one? So higher energy is this one. Okay. This is one, this is lower energy, this is higher energy. In these two, this is a high occupied molecular orbital. And what is this? This is the LUMO. LUMO. LUMO meaning occupied. U for unoccupied. These two are unoccupied molecular orbitals. In this, which is lower energy molecular orbital? So pi 3 is the lower energy molecular orbital. So this is called orbital. So this is the HOMO. So HOMO is pi 2 and LUMO is pi 3. Okay. And in between these two, that energy barrier is there. Energy barrier antam. So this is energy barrier. Energy barrier. Energy barrier means when we give the energy, the electron excited from HOMO to LUMO. ఏమవుతాయి ఎలక్ట్రాన్స్ ఇక్కడ నుంచి ఇక్కడికి జంప్ అవుతాయి. When we give the energy to the 1, 3 butadiene, the electrons are jumping from HOMO to LUMO. The electrons are jumps this barrier. ఈ barrier అంటే ఏంటి? బార్డర్. ఈ బార్డర్ దాటేసి జంప్ అవుతాయి. ఓకే. సో దిస్ ఈస్ ద ఎనర్జీ డిఫరెన్స్ బిట్వీన్ ద హోమో అండ్ లూమో. ఇది ఎనర్జీ గ్యాప్ అంటాం. సో ఎనర్జీ గ్యాప్ ను ఎనర్జీని మనం ఇచ్చినట్లయితే, సో this electron it jumps from HOMO to LUMO. So this is what HOMO-LUMO concept. HOMO-LUMO concept. So this is the molecular energy diagram of 1, 3 butadiene. Okay. So clear? Next to benzene. So the 5 molecular orbital diagram of benzene. 5 molecular orbital diagram of benzene. Clear అది? సో మీరు షేడ్ చేయొచ్చు, లేకపోతే సైన్స్ పెట్టారు. సైన్ పెట్టినా సరిపోతుంది, లేకపోతే ఏదైనా కలర్ షేడ్ కొంచెం ఎఫెక్టివ్గా ఉంటుంది. సో నెక్స్ట్ of benzene. What is the benzene structure? Three pi bonds are present. So these pi bonds are not in a position. they are delocalized. They are delocalized in the benzene ring. So before in the structure 3, 4, 6. So before current position, but after delocalization, the pi bond position will be changed like this. So with position అనేది change ఉంటుంది. So means that pi bonded electrons are involved in the delocalization. ఓకే, delocalization లో ఇన్వాల్వ్ అవుతూనే ఉంటాయి బెంజిన్ స్ట్రక్చర్. అండ్ సి 5 molecular orbitals are formed. So the number of 5 molecular orbitals is equal to number of 5 molecular orbitals. Number of 5 molecular orbitals are equal to how many? Number unhybridized p orbital. Number of unhybridized p orbital. So each carbon has one unhybridized p orbital. So that how many carbons are present in the benzene? 6. How many carbons? Each carbon is in the formation. So total equal to 6. Is equal to 6. Orbitals అనేటివి ఫామ్ అవుతాయి. Okay, and how can we draw the 5 molecular orbitals by maintaining the nodes? Maintaining nodes. Okay, nodes maintain చేసుకుంటూ ఎలా రాయాలి? So what are they? They are pi 1, pi 2, pi 3. So these are bonding molecular orbitals, and pi 4 star, pi 5 star, and pi 6 molecular orbitals. Okay, pi 1, pi 2, pi 3, and pi 4, pi 5, pi 6 are the anti-bonding molecular orbitals. These are the 6 molecular orbitals in the benzene. Okay, right. So here by main nodes, the molecular orbital. Okay. So ఇక్కడ రాసేటప్పుడు ఫర్ pi 1 molecular there is no nodes. Okay, the number of nodes is equal to 0. Okay, and see circular in the closed rings. In the closed rings, so here number of nodes per pi 1 is equal to 1, and number of nodes per pi 2, pi 3 is equal to 2, and pi 4, pi 5 is equal to 3, and pi 6 ki 4. This nodes for the number of nodes for the cyclic structures. Cyclic structures different గా ఉంటుంది నోట్స్ కు. ఓకే, అదే ఇప్పుడు ఇంత ముందు ఏంటి ఏ సైక్లిక్ స్ట్రక్చర్ అంటే సైక్లిక్ గా ఉంది. 1,3 బ్యూటడైన్ ఎలా ఉంది? ఓపెన్ స్ట్రక్చర్. ఇట్ ఈస్ ఓపెన్ స్ట్రక్చర్ కాబట్టి మన ఆ ఫార్ములా ఫాలో అయినాం ఏది నోట్స్ కోసం. బట్ హియర్ ద నంబర్ ఆఫ్ నోట్స్ ఫర్ 5 molecular orbitals, pi 1 is equal to sorry 0 కదా 0, and pi 2, pi 3 1, and here 2, and here 3, sorry 0, 1, 2, 3 like this. Okay, so for pi 1 molecular orbital 0 nodes, pi 2, pi 3 1, pi 4, pi 5 2, and pi 6 3. Okay, so అలా మెయింటైన్ చేసుకుంటూ మనం 5 molecular orbitals డ్రా చేయాలి. See, so in this 3 are bonding molecular orbitals, and these 3 are anti-bonding molecular orbitals. So there here energy barrier in between the orbital. This is the energy barrier. Okay. And at lower energy pi 1 molecular orbital is pi 1 molecular orbitals are formed like this. So how many nodes you have to maintain? How many nodes? 0 nodes. 0 nodes means all lobes are having same sign. All top lobes are having same sign. All top lobes. Top lobes ante, so these are top lobes. These are top lobes. Okay, so అన్ని ఒకేసారి కలరింగ్ ఇద్దాం, రైట్. అండ్ నెక్స్ట్ ఇక్కడ pi 1 ఇదేంటి pi 1 and number of nodes and ఇక్కడ pi 2 molecular orbitals, pi 2 molecular orbitals. So like p orbitals, cyclic structure no, are through the bond, through the atoms. We can draw the node through the bonds. Through the bonds, we can draw like this nodes. So how many nodes are present for pi 2? 1. For pi 3 also 1. So kabatti, so one node is passed through between the bonds. ఎంత కదా ఇది ఒక బాండ్ ఇది ఒక బాండ్. ఓకే, మరి యాక్చువల్గా పై 2 అంటే ఎన్ని రావాలి? నెంబర్ ఆఫ్ బాండ్స్, నెంబర్ ఆఫ్ నోట్స్ ఎన్ని రావాలి? 1. సో 1 ఎలా డ్రా చేస్తాము? ఇలా డ్రా చేయలేము. ఇప్పుడు ఒక ప్లేన్, ఒక నోడల్ ప్లేన్ ఇక్కడ వరకు స్టాప్ చేయలేము. దాన్ని కంప్లీట్ గా ఆ సైక్లిక్ స్ట్రక్చర్ కట్ చేయాలి. కట్ చేస్తే ఎన్ని అవుతాయి? ఇక్కడ ఒక నోడ్ అయితే ఇక్కడ ఒక నోడ్ అవుతుంది. టోటల్గా ఎన్ని అవుతాయి? నోడ్ 2 అవుతాయి. అండ్ అలాగే ఇక్కడ కూడా. కాబట్టి మరి సైక్లిక్ స్ట్రక్చర్స్ కు ఇది మెయింటైన్ చేయాలి. pi 2 pi 3 1 అండ్ pi 4 pi 5 2 అండ్ pi 6 కి 3 నోట్స్ మెయింటైన్ చేయాలి. ఓకే, సో ఈ విధంగా నోట్స్ మెయింటైన్ చేద్దాం. అండ్ అలాగే సో ఈ ఆటమ్స్ ద్వారా పోతుంది. ఒక నోడ్ ఏమో త్రూ ద ఆటమ్స్ అండ్ వన్ నోడ్ ఈస్ త్రూ ద బాండ్. ఓకే, సో లైక్ దట్, సో we can maintain the nodes. And next pi 4 and pi 5, pi 4 and pi 5, and next finally pi 6. Okay, so for pi 4, pi star 4, how many nodes are there? For pi star 4, so this is pi star 4 and this is pi star 5. ఎన్ని నోట్స్ మెయింటైన్ చేయాలి? 2 nodes. ఎన్ని నోట్స్ మెయింటైన్ చేయాలి? 2 nodes. సో the 2 nodes can be maintained like this. సో ఇలా అయినా మెయింటైన్ చేయవచ్చు. ఓకే, అండ్ in this one is through the bonds like this, and in this so through the bond అన్ని కూడా bonds, through the bonds like this. ఓకే, సో ఇలా మనం నోడల్ ప్లేన్స్ డ్రా చేయాలి. సో మరి చూద్దాం. రైట్, సో see in this pi 1 how many nodes? 0 nodes. కాబట్టి all the top lobes are in same shade. ఓకే, అంటే టాప్ లోబ్స్ అన్ని కూడా సేమ్ కలర్. ఓకే, ఆల్ ఆర్ పాజిటివ్ కలర్, పాజిటివ్ అనుకుందాం. ఇదేంటి? పాజిటివ్. సో దిస్ ఆల్సో పాజిటివ్. ఓకే, దిస్ వన్ ఆల్సో పాజిటివ్ like this. Okay, so all are same lobes. అండ్ నెక్స్ట్ ఇక్కడ, సో ఇక్కడ ఇంపార్టెంట్ నోడల్ ప్లేన్ మెయింటైన్ చేయాలి. నోడల్ ప్లేన్ చేయాలంటే one is above the plane and shade the one is above the plane and one is below the plane, right? Like that we maintain node here and here also. ఇక్కడ కూడా చూడండి, ఇక్కడ నోడ్ లేదు కాబట్టి సేమ్ షేడ్, నోడ్ లేదు కాబట్టి సేమ్ టాప్ లోబ్ ని మనం షేడ్ చేయాలి. రైట్, ఇక్కడ నోడ్ ఉందా ఈ రెండింటి మధ్యలో? నోడ్ లేదు కాబట్టి సో దిస్ లోబ్ ఆల్సో షేడ్ విత్ సేమ్ కలర్. టాప్ లోబ్ ను సేమ్ కలర్ తోటి మెయింటైన్ చేయాలి. చూడండి ఇక్కడ నోడ్ ఉంది కాబట్టి ఆపోజిట్ ఆపోజిట్ లో షేడ్ చేయాలి ఈ విధంగా. ఆపోజిట్ లో ఈ విధంగా షేడ్ చేయాలి. అండ్ నెక్స్ట్ ఇక్కడ నోడ్ లేదు కాబట్టి బిలో లోబ్ ని షేడ్ చేయాలా, అబో లోబ్ ని షేడ్ చేయాలా? బిలో లోబ్ ని షేడ్ చేయాలి. సో ఇది. సో like that we draw the 5 molecular orbitals of the 5 2. Okay, and next ఇక్కడ. So here lobe is there. So shade with above top lobe shade by shade like this. And next the node between ఎక్కడ ఉంది, ఎక్కడ? సో బిట్వీన్ దీస్ టూ అనుకుందాం. సో ఇది యాక్చువల్ గా ఇది డ్రా చేయకుండా ఏం కాదు. సో ఈ విధంగా డ్రా చేద్దాం. సో ఇక్కడ సేమ్ కలర్ అండ్ ఇక్కడ ఆపోజిట్ కలర్ పెడదాం, సారీ బిలో పెడదాం. సో దిస్ ఇస్ ద నోడ్ అండ్ రిమైనింగ్ అన్ని so here also no node shared with shade like this, and here there is a node kabatti like this. Okay, like this. So we maintain the nodes and ikkada see in between these two node is there. సో ఈ విధంగా షేడ్ చేయండి. అండ్ ఇక్కడ నోడ్ ఉంది. సో నోడ్ ఉందా? నోడ్ ఉంది కదా, నోడ్ ఉంది కదా ఆపోజిట్. అండ్ నెక్స్ట్ ఇక్కడ ఏమొస్తుంది? షేడ్ అయింది. అండ్ నెక్స్ట్ అండ్ దెర్ ఇస్ నో నోడ్ కాబట్టి ఇక్కడ మనం ఇక్కడ షేడ్. ఓకే, ఎలా వద్దు, ఎందుకంటే ఇన్ బిట్వీన్ దీస్ టూ నోడ్ ఇస్ దేర్ కాబట్టి ఇక్కడ బాటం నోడ్ లేదు కాబట్టి. ఓకే, సో అలా. సో ఈ విధంగా మనం మెయింటైన్ చేయాలి. అండ్ నెక్స్ట్ ఇక్కడ సో ఇన్ బిట్వీన్ దీస్ టూ node is there kabatti one top and one bottom, and ikkada so there is no node. Okay, so there is no node. So ikkada first ee node unnadi maintain chedam. So ikkada enti so ikkada enti node undi kabatti ఇది టాప్, ఇది బాటమ్, రైట్. సో ఇక్కడ ఏం నోడ్ లేదు కాబట్టి ఇది బాటమ్. సో నోడ్ ఉంది కాబట్టి ఇది టాప్. ఓకే, అండ్ ఇక్కడ నోడ్ ఏం లేదు కాబట్టి సో నోడ్ ఏం లేదు కాబట్టి టాప్. సో ఈ విధంగా షేడ్ చేయాలి. అండ్ నెక్స్ట్ ఇక్కడ ఆల్టర్నేట్ షేడ్ చేసుకుంటే వెళ్ళండి ఇక ఆల్టర్నేట్. సో ఇక్కడ నోడ్ ఆల్టర్నేట్ షేడ్, ఒకటి డౌన్ ఒకటి టాప్, వన్ డౌన్ one top. ఆల్టర్నేటివ్ గా షేడ్ చేసుకుంటూ వెళ్ళండి. సో దిస్ ఇస్ ద మాలిక్యులర్ ఆర్బిటాల్ diagram. Molecular orbital diagram. And, and see, and how many are there in the benzene? How many pi electrons? Six. 6 pi electrons are there. You have to fill the 6 pi electrons. Atom 2, and here third, fourth, fifth, and what is the LUMO and what is the HOMO? What is LUMO and HOMO? So this is, and highest occupied molecular orbital ఏంటి, lowest unoccupied molecular orbital ఏంటి. Highest occupied molecular orbital, unoccupied molecular orbital. Okay, highest HOMO, this is LUMO. Okay, 5 star 4, 5 star 5 are not filled by the electrons. So కాబట్టి lowest unoccupied molecular orbital, and this is filled by the electrons, so that it is highest occupied molecular orbital, and this one lowest unoccupied molecular orbital. So this is about the high molecular orbital diagram of benzene. So next, what is the bond order? What is the bond order of benzene? What is the bond order of benzene? Benzene bond order ఏంటి? How many bonds are present between the atoms? Sometimes 2 and sometimes 1. Okay, so అప్పుడప్పుడు ఈ రెండింటి మధ్య ఏమున్నది, 2 ఉన్నాయి. ఈ రెండింటి మధ్య ఏమున్నది, 1 ఉంది. సో 2 అంటే 1 is permanently and second one is one bond is present permanently and one bond is rotating around the circle. So కాబట్టి one bond is present permanently and one bond is, so that the bond order is 1.5. The bond order of the benzene is, see, 1.5. ఈ బాండ్ ఆర్డర్ ఎలా వస్తుంది ఫర్ సైక్లిక్ స్ట్రక్చర్స్? ద బాండ్ ఆర్డర్ is number of resonating bonds by number of resonance structures. So number of resonating bonds. So how many bonds resonating? 3. Bonds resonate. How many number of resonating bonds? Number of bonds involved in the resonance. Any? 3. 3 by how many resonance structures are possible? 2. This is the one and this is the another. So 3 by 2 gives 1.5. So like that, the bond order of the benzene is 1.5. So ఇలా క్యాలిక్యులేట్ చేయాలి బాండ్ ఆర్డర్. అలాగే సో ఇది మనకి ఇంకేమైనా టాపిక్స్ ఉన్నాయి దీంట్లో? ఏం లేవు. సో ఇది చాప్టర్ 1 నుంచి. చాప్టర్ 1 యాక్చువల్గా మనకు టైం లేగా ఫాస్ట్గా చెప్పాల్సి వచ్చింది, అండ్ మధ్యలో ష్రోడింగర్ వేవ్ ఈక్వేషన్ మనం స్కిప్ చేసాం. ఎందుకంటే డెరివేషన్ పార్టే కాబట్టి అది చూసుకుంటే వస్తుంది. సో అండ్ ఏంటి ష్రోడింగర్ వేవ్ ఈక్వేషన్ అండ్ పొటెన్షియల్ పొటెన్షియల్ particle nature in one dimensional box. Particle nature in one dimensional box and Schrodinger wave equation. సో ఈ రెండు కూడా మనం డెరివేషన్ పార్ట్సే కాబట్టి సో అది లీవ్ చేసాం. సో ఇంకా దీంట్లో ఏమైనా డౌట్స్ ఉంటే అడగండి. నోట్స్ సో ఎలా ఫామ్ అవుతాయి? బై నోట్స్ మీన్స్ ఆపోజిట్ లోబ్స్. When opposite lobes are come together, there is a node. When opposite lobes are come together, what happened? The overlapping will be 0. Okay, one lobe cancel with another lobe. Plus is cancel with minus. So there is no orbital. Orbital lekapothe the probability of finding electron is 0. So where the probability of finding electron is 0, that is known as node. Okay, so by maintaining nodes, you can draw this pi molecular orbital diagram. సో నోట్స్ మెయింటైన్ చేసుకుంటూ డయాగ్రామ్ డ్రా చేయాలి. ఓకే, సో డ్రా చేస్తే మనకి ఈజీ అయిపోతుంది. రైట్, ఇంకా